series data, since there can be lacks of unknown, almost like computer architecture, we have the AND gate, OR gate, exclusive OR gate, like this one. You can analogy this one to the simple task which you already learned. That topic is called here. The forget gate controls the extent to which a value remains in the cell, and the output gate controls the extent to which the value in the cell used to compute the output activation of the LSTM unities. The activation function of LSTM gates is often called logistic sigmoid function. Yes or no? 1 or 0. Sigmoid is 1 or 0 function, which is a part of machine learning that comes into picture is called sigmoid. -1 to +1 is called. So there are connections into and out of the LSTM gates, a few of which are recurrent. The weights of these connections, which need to be learned during the training, determine how these gates operate on. This is the LSTM. Because of time shortage, I'm not elaborating this particular task is called. Okay. Now we go to the third module of this particular lecture. Okay. We'll go to this third one. These are the methods which are right now we are following, right? And let's see the applications of this one is called. What are the trends are happening in this machine learning as well as this deep learning concepts point of view is. The advantages what you have seen is called. So it does feature extraction needed for engineering features, moving forward towards raw features, better optimization, a new level of nice robustness, multitask and transfer learning, better architectures. What are the challenges we have? The challenges are there. So need a large data set, which I said we need. You see, call all three of them. Says I need large data sets compulsory required. We need a large data set. Training time is usually significant. Automatically signifies. The scale of a net's weight is important for performance. When the features are of the same type, this is not a problem. However, when the features are heterogeneous, it is a problem. Is parameters are hard to interpret, although there is a progressive being made. So hyperparameter tuning is a non-trivial. So come to this one is called, what you have is called applications of this deep learning is. Let's see this one. I need another PPT. Just please wait. The first and foremost, what you require for this call is ultimately what is required for everything is called. We need to here now call the best of the best food and the best facility for us to live happily here now is called. Right or not? Today is called, there is a strike is happening nationwide. The farmers are doing. So related to this one is called agriculture challenge only we have this is called. So how do you bring the technology into the agriculture sector? Is so when you brought this is called this particular technology into the agriculture, the most beneficiary is called, of course, we are the beneficiaries, and the best beneficiary is called farmers. So how do you do this particular task is now let's combine. You can leverage the technology and agriculture. The world population here now is, look at this is called how much fast is going on. So we the Indians have populations of 135 crores, right? And you can see called here now, world population is called 700 billion population we have. So when you see this one is called population point is rising every day. And how do you meet all these things are called? The demand of agriculture is population, more people. So consumption is higher demand. So capita is higher. Consumption is increasing. Population is also increasing. Here now one solution brought was green revolution. So maize, rice, wheat, soybean, the yield is increasing, right? So crop yield must increase 60% to meet demand by 2050. The crop yield must increase 60%. Right now from here onwards, it must increase. If you want increase means cannot, there is no land here now. No? Here now the oceans are coming to here now, right? We are losing whatever they have called the land we are losing because the water is coming and taking the entire one. The oceans are coming to the beaches. The beaches are coming to our houses. right? Now we can see here now. The briefly is 2,500 million current world population cereal production. Corn demand to support current use per capita beef consumption for a population of 7 billion because they eat non-veg. That's why that's an example is called. It's possible. I now say that the world has the technology to feed on a sustainable basis a population of 10 billion people. Normal Borlang is a person who said about this is called data science. How data science meets this one is called green revolution, biotech revolution, green data revolution. Okay, this is the example of data sciences. And come to our point is called machine learning. So yield optimization, optimize yield. Yield optimize for environment by optimizing the genetics and management using the predictive model. Yield optimize for environment by optimization of genetics and management of traditional practices. So what are the here challenges is called spatio-temporal data, sparse data, missing data, noisy data. Data challenges. Learning challenges are latent features, curse of dimensionality, multitask. Yeah, now. So one season, one crop, one country, yield monitor data, 114 14 billion observations, 260 billion observations. Weather data is 20 billion observations. So feature engineering is latent space, genetics, environment, practices, soil processes, nutrition process, crop process, yields. So latent features scope, what you have, casual description. There we have, this is the concept of feature. The role of deep learning is called feature learning is called here. So yield is, so generic environmental practice, deep neural network, left side you can see, right side you can see hierarchy, dimension reduction form. So physical models, genetics, environment and practices, soil processes, nutrition processes, crop processes is yielding. This one is. So spatial data is one example. This is a time to give an example in this one is there it is possible we can bring that deep learning into considerations. Multitask learning is the one where it is how the people are interested in this one. We can practice this one also. And we can see a deep belief network, which is a part of again called neural network we have. Where possible. Other applications are possible like this way. Crop identifications, disease detection is possible. We can see this one is image segmentation, clustering, cloud detection, environmental classification, nutrition deficiency detection, remote sensing, practice classifications. All these things here it is possible. You can use this deep learning in this class. Example, let's take example here now. The farmer would like to know here now. There is insect is there. So the crop is unable to get the particular insect is eating the entire crop. So you would like to know what is the what are the precautions to be taken to avoid such type of things is called. So farmer is a remote place and the data scientist who is there, the domain knowledge engineer person is called the expert who is the agriculture knowledge is there. The person is at the university, agriculture university. Now they would like to talk each other. So farmer, what he does is he takes a picture and sends to that one. The picture is not a clarity is there. It's a blurred image. Now use the farmer is. So farmer cannot read it and farmer would like to know that into text, into the speech form. So convert the text into the speech form. And also it is possible here now, as an advanced technology, you would like to see it's also possible way you can convert that voice into the what is called into the speech. You know, a person comes and he talks entire things are because of we the people I already said we like images, we don't like the text, we don't like the not that much of audio. Audio we like only when you're doing some other activity, we watch, we hear the audio. But when you're free, we like to see the audio with the video only. So we the people always prefer the video. So now the convert, what we do is called the we convert that entire audio into a human comes there and that human conveys the message to the farmer is. So these are all technologies are possible where you can do this one is. Let's see one more applications of this one is. One more application, let's see this one. So this is a where it's possible is a very advanced topic here now. Very, very advanced one. So this is a PDF form is open that one. Just 1 minute. Okay, I'll share. So medical imaging. The second other one is called medical imaging one. Application is medical imaging. So 5.4 million cases are non-melanoma skin cancer each year in the US. So skin cancer point of view, how we use call this deep learning is. So skin cancer in the US, here now 5.4 million cases every year. 20% of Americans will get skin cancers. So acidic keratosis, that's called pre-cancer, affects 58 million Americans. 78K melanomas each year, 10,000 deaths. So 8.1 billion in US annual cost of skin cancer. So success here now called mammographic mass classification, brain lesions, airway leakages, diabetic retinopathy, prostate segmentation, breast cancer metastasis, skin lesion classification, bone suppression in chest X-rays. Their success already got it. What is deep learning in this one? Let's see. So AI neural networks composed of many layers, which I said, learn like humans, automated feature learning, layers like image filters. Layer one, we are finding image, edges, combinations of edges, and object models. So this is input layer, layer one, layer two. Okay, one by one is extracting, and so many outputs we are going to get from this one is. So medical imaging processing is pre-trained networks with the transferring learning, UNet, VNet, ENet, all these things are examples of this one is. FCN, fully conventional net with skip connections, multi-streams CNNs, TiNet, dense CNNs, encoder plus RN decoder, multi-level classification, FCN plus MDP-RL for two-dimensional 3D image registrations. These medical image models, you can see this one is, this is a process. You can see the process of this one is, this for example point of I'm explaining. So specialized computing, special purpose cloud, Google TPU, Microsoft Brainwave, Intel Nirvana, IBM Power AI, NVIDIA V100. So CPU, GPU, FPGA, custom ASICs, there are things are required. And optimizations, when you want to medical imaging, what are the things to be required? These are all required, then it is possible. So TensorFlow is a one technique which will use it here now. OpenCL is one technique which uses Python. So it's possible where you can do the computations of deep learning is. So TensorFlow CPU optimization, compile from source, run. This is the way we can do the processing of this one. So parallelize your models are data parallelism and model parallelisms is one technique. Optimization for training is this is the way we can do the optimizations of this entire one. So partitioning of workloads is one technique. Optimizations for inferencing is one technique. Okay. So there's a time we can definitely will have a one particular session. It is possible. Okay, particular session. Let's come to the original presentations where I'm talking about trends point of. Let's see the one more. 2 slides are there. Let's see this one. There are 2 slides which I need to explain. Okay, right. Not sharing, just wait. It's not coming. So there are trends: automatic colorizations of black and white images, automatically adding sounds to silent movies, automatic machine translations, classification in photograph, automatic handwriting generation, automatic text generation, automatic image caption generation, automatic gameplay. So these are some of the trends right now happening here. It's all these things here now already have seen some examples. So when you would like to convert the picture into the black and white to color one, colors to the color count, your interest, you can, if you want to change any of the color of this image, it is possible using the deep learning. Automatically adding sounds to silent movies when you want to add, okay, sounds to the movies which already previous movies, silent movies are there. For example, Charlie Chaplin, all movies are silent movies only music comes out. No, here now called conversation happens, but we are able to understand the movies. So, but I'd like to add sounds. Now it is possible. We can do that activities here using this one. Machine translation. Automation translation is one technique where we can convert one language to other language. So when you're moving from one place to other place and their language, he is speaking one language. Suppose you went to Chennai and the person is saying something, right? And you would like to get your own language. So how do you do this one? Previously, we used to have 30 days learning language. 30 days, within 30 days you can learn, not required now. So whatever he is talking, just record the voice and use the app and convert into your own language. That's called automatic machine translation. What he's talking, it is possible for us to know that. Also called object classification detection in photographs. So what are the object I will need to identify? Like example, Facebook, I said, no? The Facebook, when you upload a photograph, he's saying this person is there, belongs to something. So automatic handwriting generations, automatic text generation, and automatic image caption generation. All these things comes an examples of automatic game playing. It's a chess game, right? Is one of the game we just here happens here. So when you're talking about chess game point of view, which is example right now, I would like to give one example here now called. I explain. I tell you that is which is missed here. Google Go is the one game is there. Black and white images. Black and white you need to take and you need to play that one. Is very interesting game that is. The feature scope what you have is called deep learning will speed search for extraterrestrial life. So robots, short for robotic exploration recognition for exoplanets that are beyond our solar system. That can be used here. For astronauts, next step on journey to space will be virtual. That's the one thing. Dots and deep learning, measuring water where it is square. Where it is possible also, we can use this one. The final one I would like to tell you in this particular presentation is called the low maturity of deep learning and its applications such as large deep neural networks achieve the best results on speech recognition, visual object recognition, and several language-related tasks field warrants extensive future research.
All the participants, please mute yourselves.
Somebody left the phone there, and nevertheless, the possibilities of deep learning in future are infinite, ranging from driverless cars to robots exploring the universe and to whatnot if the upcoming architectures are creative enough. So what here now called used is called here now is the deep learning real practical applications according to the present time is called is social distancing. To know here now called the 3 meters or 2 meters social distance in maintaining or not is possible for us using this deep learning is. So the distance identifies one person other person. So simple distance using formula, because we need how called, when I capturing the image, we need 3D. Okay, and identify the distance between two people and do the computation tells is called. There is a beautiful algorithms are used, and almost all the airports they are using this one is called. It can, the simple one, the program is inserted into the video camera, and the camera captures this is maintaining or not. If anybody is not maintaining the distance is called, it gives a warning symbol. Right? If anybody is talking to each other, between the two people, they are sitting and talking to each other, and the distance is less than 2 meters, and it gives a warning. Okay, the person comes and says we need to maintain distances. Like this is here. To maintain the distances here, social distances, deep learning are using right now. Most of the companies are using this type of speech. So,
All the participants, please mute yourself.
So that's all from my side, madam, on the presentation. Thank you for
Sir, I have it.
madam, please. Otherwise, if you're able to, you just type it in the chat box so that it's possible.
Okay. Sir, can I ask, sir, can I able to audible?
Yes, madam, you're audible. You're audible, please.
Sir, is there any deep learning technique to predict the future requirement of any of the task or future requirement of process execution, or is any deep learning algorithms are available, sir? Hello?
Yes, madam. Sorry, my phone was muted. Okay. Predictions point of view, deep learning won't come, madam. No. Prediction point of view won't come.
No, sir. Prediction.
No,
like...
no. Predictions, no, madam. Only you need to go for the machine learning techniques only. Called supervised learning point of view. It is possible. Good question.
Okay. So we can't able to get any of the execution time of process or any of the requirements of how many resources it required. We can't able to predict in future beforehand itself.
No.
Okay. Thank you so much, sir.
Hello, sir. I would like to interrupt in between. But sir, according to we are working on COVID predictions model. So we are able to predict it out, sir, in month of January and month of February, how much the COVID cases will be there, and so certain cases we are able to predict it out, sir, in case of deep learning also. I think so.
Yes. No, we need to use algorithms which are exist in the machine learning. Machine learning algorithm.
Actually, sir, deep learning, like if we are talking about even CNN or whatever model available, we can go ResNet and all those models. So what the prediction is nothing but based on the past data, we can predict the future. The trend. Yes, sir. The trend being followed previously, like we have the previous data and we have labels also. And then based on that previous data, we can predict the futures and how it could be. It may not be exact, but it could be, it gives an idea, sir. I think so.
Yes, right. Exactly. This is called, what you have is called machine learning techniques. Can be by combining the machine learning techniques, then it is possible. Exclusively for deep learning, no techniques. That's why I said deep learning is a subset of machine learning. So all machine learning techniques can be used as a part of deep learning. That's plus point.
That's okay, sir. But I mean, just ma'am asked about whether deep learning could be used for prediction purposes or not. So that's also, what I thought it could be.
That's right.
Thank you.
Sir, if we are able to predict the things, actually, can I know what type of algorithms I have to search in machine learning so that I can go forward my
Okay, right,
area?
right, madam. We have logistic regressions. We have, madam. Logistic regressions we are available. It's using
Okay.
that technique is possible.
Okay, thank you, sir. Thank you. Yeah, I will search around. Okay.
Yes, please go search that one. It's available.
Yeah.
So we have a group also. I'm also the part of the WhatsApp group, and we'll have conversations. All these things we can do the combined research work also is possible. So let's have a nice research group so that it is possible for everyone else to work more in this particular topic. Is
Any more questions? Any more questions from participants?
Yes, I typed one question in the chat box. Can we have any case study where deep learning helps the farmer?
Hello.
Vandan Babu garu, please.
Yes.
Sir, apart from convolutional neural network, what model could be used for automatic feature extraction?
Can you repeat the question? It's not that.
Apart from CNN, because convolutional neural network, which used for the feature extraction purpose, automatic feature extraction purpose, what other techniques, what other deep learning models could be used for automatic feature extraction? Sir, you are muted, I think so.
Right. What are other techniques? What do you have? Apart from convolutional neural networks, is image, especially feature extraction point of view is okay.
Yes,
Let me check it. Definitely, Vandan Babu, definitely I'll respond to this one. Thank you for asking.
Sure, sir. Thank you.
Let me check and respond to this one.
Excuse me, my name is Vadan Babu. I asked another question.
So, Mr. Hari Mohan Rai.
Yes, sir. Yes, sir.
Okay, you're asking. You're Hari Mohan. Thank you.
Thank you, sir.
Somebody is asking background. I think noise is.
This is Vadan Babu. Prasad, sir. Hello, Prasad, sir.
Hello, please.
This is Vadan Babu.
Vandan Babu, please. Please.
Can we have any case studies where deep learning helps the farmer? This is my question. I want some case studies. So, sir, I typed the question, sir, here.
Okay, sir. We are running out of time. Shall
Yes,
we
madam.
stop for today?
Yes, madam.
Okay, sir. Over to you, Namrata ma'am.
Yeah. Thank you, Dr. G.N.R. Prasad, sir. We are grateful for the time and effort you took to share your thoughts and experiences on trends and methods of deep learning. Thank you, sir.
Yes, ma'am. Thank you very much. Thank you for giving the opportunity to all of you. Thank you.
Yeah.
Very nice time spent with all of you, and very happy, memorable moments. Thank you all.
Yeah. Thanks.
Yes, sir. Great pleasure to have you here.
Yeah.
Thank you, sir. And all the participants will take a break of 10 minutes and will be back at 11:45 for our second session of day 2. We'll have a break now. Thank you.
Ma'am, is anywhere attendance forms we have to fill it up, ma'am? Because yesterday I got.
Ma'am, your attendance has been recorded by this software itself. So if you are attending this session, so automatically the attendance will be generated. So no
Okay.
separate attendance will be taken.
Okay, ma'am. Thank you. Yeah.
Thank you, ma'am.
Ma'am, what about test link? When will we get the test link?
Ma'am, test will be on day 5, last session, third session. So we'll inform you, ma'am, in group.
And any other assignments we have to submit?
No assignments. Only these all sessions only will take an exam on the last day, 5th day.
Okay. Thank you,
It is objective only, na ma'am? Is it
yeah, ma'am, it's objective.
objective only, right?
Yeah.
Okay.
Okay, ma'am. Thank you.